Hey guys, this will be video 9 for the how to design build a 59 Korina Les Paul replica using Stuart McDonald templates. And this is going to be probably a fairly long video, but I'm going to focus primarily on the neck. But I do want to start out and spend the first 5 or 10 minutes talking about weight analysis and things like that and comparatives between 3 different guitars that are replicas. And that way you can kind of see my reasoning for why I do what I do. So, and what prompted that was somebody had commented, "Hey, why did you put a three-piece Honduran mahogany or mahogany top on a one-piece body?" Which I thought was so cool that they thought that was a one-piece body. Because it's not necessarily that I did a great job gluing it up, even though it's really good. It just goes to show you how well the Korina hides any sort of glue line. But the reason I did do the three-piece Honduran mahogany top, and the reason I said Honduran is because it's feather light. And when I buy my neck material, I buy it 3 inches by 4 inches by about 30 inches long, sometimes 32 inches long. And I always get a drop down the entire side, which I can use for remnant material. So the fact that this is a mahogany cap is it's not just a mahogany cap, it's a Honduran mahogany cap that the Honduran was intended for master level neck construction. That means it's perfectly quarter sewn this way, but then once it gets machined and laid down flat, it's perfectly flat sewn, but it's light as a feather. And it's one thing to have a mahogany guitar, it's another thing to have a Honduran mahogany guitar. And that's what everything that you're going to see, these are all, anytime you see any mahogany that's in on my table, it's all Honduran. That's all I work with. Okay, so what I'm going to do is we are going to I've already got the router set up. I'm about to route this channel like I promised in the last video. I'm going to be mixing epoxy, ripping the fillet. We're going to be gluing the fillet in and all that jazz. By the time this video is over, you'll see the neck not in that finished state because it has to dry tonight, but it'll be ready for machining tomorrow morning to level that off. So let me pause, get the scale on the table, and then we're going to do a weight comparative between these 3 different guitars. And you might think, well, that's kind of not fair because this one's not finished, but I think you'll see my reasoning behind working with the Honduran. So let me pause. Okay, we'll start with the Peter Green wannabe, the little 58 replica. Again, this body footprint is just a little bit smaller than your traditional 50s guitar, but this would be a good comparison. Maple top, Honduran mahogany, we've already covered that. Ebony fretboard, double adjustable truss rod, identical to this rod here. So we should be a fairly good comparison. This one has a bone nut on it. It has all the frets in it, has all of the mother of pearl trapezoidal inlays, and should be about a ½ pound lighter than I always wanted it to be. But nonetheless, you live and you learn. It does sound incredible. I'm going to find out which way it's wanting to roll. Okay. I'm just going to keep my eye on the guitar, but it shouldn't go anywhere as long as I don't touch the table. Yeah, it's fairly straight up down. 2,749 grams, no hands. 2,749 grams. I'm just going to watch it and make sure it doesn't. Okay. 6.060 pounds. It's pretty light. It's very light. Okay, let's tear that. Okay, this is a little bit, I don't know, it's a fairly close comparison. I'm not going to try to tell you the difference. Just you can see that the only thing this one's missing is half the frets, but and also it has no clear coat on it other than just a very small amount. Has major work right here for all the Floyd Rose, but it is chambered identical to this one, and that one that I just weighed is chambered also. So now this one is an authentic. Let me make sure that was on 0. Yeah, this one is an authentic 50s footprint per the Stuart McDonald templates. Look at that. She's standing up by herself. That's pretty cool. I'm not going to give it the benefit of the doubt though. All right, 6.528 pounds. 2,961 grams. Okay. One thing I failed to do was I'll just do the math. I'll just do the weight. Late 80s, early 90s, authentic Germany, Floyd Rose. Probably one of the best looking ones I've ever seen. I've owned a bunch of these, probably 10 or 15 of these, and it's exceptional. It's very, very clean, and very happy with that. And I got it for, I think I paid $190 plus tax and shipping and all that jazz, but it had the fat brass block on it, which I thought was very fair. And but unfortunately, it's very heavy as well. So this is the reason that I really took the router to the bank on the last guitar I just weighed. 518 grams, 1.142 pounds. It's pretty heavy. And that's before all of your springs and your claw, and I may do the Shaler, adjustable, but I gotta tell you, I think it would be adding too much weight. So hence the reason that I really took out a lot of mass on that, the back of that guitar. Okay, so now we're in the world of the Korina, and you're about to find out why I did not dare even consider going with a maple top. Grams, tear. See if she'll stand up. 2,000. Get it to stop rocking. Although the weight is not changing. 2,802 grams. 6.178 pounds just for the body. Okay, and let's start adding some. Now let's make this comparative as fair as possible. A neck husk, as you see, it's nowhere near finished. I'm not sure I'm going to be able to do this. I forgot I've already rounded this thing on the back. This might make a fool out of me. Let me try something here. Okay. 7.214 pounds. 3,272 grams. This is tricky. See where I'm going with this? 3,436 grams. 7.576 pounds. Plus we're going to have a fretboard. Frets, a few other things. However, after it's all said and done, after this video is, well, not this video, but the next video is over, this thing will take off a considerable amount of weight in the fact that I'm going to be carving a lot of this Honduran off right here, a little bit right here, about a 1/16 of an inch, and then some in the recurve. So this will probably drop about another half a pound. But when you're at this point, the last thing you can do is get complacent and go, it'll all work out on the end. No, you're responsible for engineering the guitar at least to within a half a pound. You need to have a general idea of what's going on, um, and just so that either you don't make decisions and sell a guitar that you thought you didn't like, only to end up with a 10.5 pound guitar that now you hate it, and you sold your other one that you miss terribly because it was only like what, 6 pounds or something, 6.5 pounds. This one will be taking off some weight once I route the profiles, and it'll add a little bit of weight once I put the ears on. It'll add a little bit of weight once I do the overlay, the truss rod, and all that jazz. So, nonetheless, it's still gonna be about right at 8.5 to 9 pounds. Okay, so let me pause, get organized, and then we'll go from there. Okay, had to make sure it was recording there. All right, let's talk about neck construction. I'm going to get this off the table. I didn't cover this in the last video. This is a 7/8 inch initial radius, and it's great for doing your 54, 55. Okay, 54 up to I think 58. After 58 is when they started getting a little bit smoother. Uh, but you can't just machine the finished neck. This is just the initial like rough out work. It's pretty close to finished though. So I'll get that off the table. 7/8 inch initial radius. This is a I'm sorry, 1 and 7/8 inch. I'm sorry. Yeah, I'm almost confusing myself. Okay, let me make sure I clarify this. Radius, not diameter. Radius on that red bit was 7/8 of an inch. This bit, the radius is 1 inch. It's a 2 inch diameter. What would I love to have? I would love to have a 15/16. I haven't found that yet. I'm so curious what that would feel like initially. So that's where you start. And what I'm talking about is obviously going from the S4S into the roundover. I have a jig that I designed that allows me to machine a large, not in just one pass, because I step down to the finish line, but I'm able to do the bulk of this machine work from overhead. Some guys will machine like this. That's fine on like a bolt-on neck, but excuse me. But if you have an arch top neck, with the heel, it works much better if you have this. I'm not going to go into detail about what you have to do to make certain that you don't lose that heel, but if you don't do some practice work first, don't think that you can just rough out your side profile like that and then crank up the router and put the bit up here and start routing it. You'll lose your heel. Okay, so do some test work if you're serious about this and you're actually getting ready to build a guitar. But let's talk about the truss rod. In that, how do we go about getting the truss rod in? And one of my initial notes here basically said, first off, keep the thing S4S as long as possible. Even this has the taper in it already. It has the taper. That's only because when I was building the other guitar and I was building the other neck for that guitar, everything about I was cutting it so close, trying to preserve as much wood as I could in order to get the widest part of the bout in the body, if this makes sense, that I ended up roughing this out pre-tapered. It was a rough taper, but it was already tapered. Now, if I was just building the guitar from scratch, I would much, much prefer the entire piece to just be S4S. If it's 2 and 3/16 of an inch finished width here, then I would like to have it 2 and 3/16 of a finished width right here before I glue my ears on. That way, when I'm doing all of my any machine work, I know that I've got a S4S. Where's the little board? I had a little sample board. Oh no, yeah, here it is. you know, if we're going to do some machine work to this neck and eventually end up with it radiused in a certain area and square in a certain area, or maybe we're going to cut out the heel down here and all that jazz, as long as we can keep it S4S as long as possible, we can do a lot of stuff on the table saw. And I mean a lot of the guitar neck could be built on the table saw if you can keep it S4S as long as possible. Eventually, you'll need to move to a router table, but that's just woodworking. But if you can keep it S4S as long as possible, all the better, because it makes your job so much easier. And also, it would allow you to, if you wanted to, you could run this truss rod channel. You could cut this truss rod channel on a table saw. It's fairly simple. I don't like that though, because I'm always pushing myself to 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 perfection. And if the bottom of my truss rod is radiused, then I want the bottom of my channel to be radiused as well. Okay, that guarantees that I've got a precision fit in everything. I've already covered this numerous times in past videos, but I have to treat this video as if no one has ever watched those. So if that makes sense, it'd be real simple. If this were still 2 3/16 width all the way up here, to just throw this up on the table saw, cut that 1/4 inch roughly channel all the way down, and then drop this baby in and be ready to build a neck. But because I'm about to show you my order of operations, I think you're going to see that it's a far more precise finish once you cross the line. So we talked about the radius stuff. We talked about the rough layout. If we can keep it S4S, that's awesome. It's not S4S, so now I'm going to be relying on a template a jig that I designed that is, I can't find it online. It's amazing. I can't believe no one has already presented this thing to the Weekend Warrior woodworkers, but it's so simple. And basically, it's just a straight edge that allows me to put this in a fixture and do all this machine work, whether it's on a router table or whether it's on a table saw. That's for I call it my straight lining jig, for like cutting straight lines. Whether those straight lines are on a S4S parallel to the center line, or whether they're on a trapezoidal path to the center line, I can take that jig and do that work. And if I'm on a table saw, I don't have to worry about the blade pulling or pushing the material. But if I'm on a router, a table router, the router is turning counterclockwise, looking at it from the top. So once you go into that router bit, it's going to want to push your work over to the side, or it's also going to want to grab. Once you start getting in there, sometimes it'll want to grab your work and start pulling it. So you have to make certain that you're working off the right side of. Let me think. And I'm about to do this. Yeah, you're working off the. I'm wrong. You're working off the left side. I already processed it. You're working off that side of the little template, because you've got a fence on your router table like that right there. So your jig will be traveling in this path right here. Okay. And if your jig is really wide, well, then your fence just goes over whatever distance you need to allow your large jig. Your fence goes over far enough to allow your jig, whatever width it may be, in order to be very close to center. Because we all know that on the router table, we're working from a pivot point. We're not necessarily sliding that like a table saw. At least mine's not. It's a handmade router table. I work mine off a pivot. So, okay. So I'm about to do that. But the reason I'm showing this little bit first is because my table is a handmade table. I don't even measure anything. I will measure and get a rough idea, but I start out with a 1/8 inch bit in order to make little kiss marks to determine where the center is. And then I'll start moving the fence in order to assure that I get on center. And then once I find center with that, I've got this fence over here is set up to where I can toggle clamp it down, and I know it's locked into position. And then since I have the center there, any bit that I put in that router will be on the center of my workpiece. Okay, and not that you would do that, but you're anything you put in that router bit is going to be on center with your workpiece. And then it will just be up to you to identify where you're going to be stopping. And so that once because you won't be able to see a bit at work, but you'll need to know when to stop, so that if you're going to do this really high-end precision work, well, let's make sure that we don't screw up and go 3/4 of an inch too far, because then we'll have to glue in some blocking and stuff like that. So you've already engineered exactly where you want this baby to land, and according to your pitch, and so that your truss rod is not sticking through, because then you would not be able to get your truss cover on there. So got to think about all these things, which I'm about to go pull the trigger on the tool and do that job, and then we'll come back and talk about it. And I'll go through the different operations where I'm going to put this bit in first. I'm going to find the center. I'll show that to you. Then I'll change over to this rough out bit. Then we'll radius the bottom, and then we'll cut for the just the end out here to receive. I don't know what that's called. It would be the truss rod nut location, but it's kind of like the truss rod nut housing. Okay, so that'll be the last bit, but I will only cut about 1.25 inches deep on that one. So a lot of different little operations are about to take place, and I'll be pausing probably 5 or 6 different times. So let me go set the jig up and do that work, and next time we see it, we'll have a identifying location with that bit right there, 1/8 of an inch. Hey guys, I'm going to change gears here a little bit and cover something that I think will make it much easier for someone who doesn't have the ability to work with a router, because I got thinking, I want to assume some responsibility for helping you guys stay as safe as possible. So I'm not going to show you my other jig, but I want to show you something that I did recently, where I took a neck that I had built, and I actually cut out all of the work that I did because I wanted to make the neck thinner, but I knew that I couldn't make the neck thinner because I had dropped this truss rod down into the neck. So I had to cut this truss rod, every bit of the work out, and remove the truss rod and make the changes necessary in order to bring it up a little bit so I could do that work. And how did I do that? Well, it wouldn't go on my jig because it has a radius back. And so what I did, I thought, well, all I need is just a straight edge to keep me on track there. So based on that, since I mentioned, you're already working against the router fence, which is going to be on the right side of the bit. Okay, not going to cover that again. We've already covered that. So your jig is going to be passing along this point here, and it's going to be cradling your neck. Now, part of your neck will be cantilevering, so you got to make certain that you really have this well fastened to this alignment. So what sort of route are we cutting? It's 1/4 of an inch wide. So based on that, we step off 1/8 of an inch off center and make a mark there, and 1/8 of an inch center off the mark here. And all we got to do is temporarily glue or attach, however you want to do it, the neck to that right there. And then we're able to then put this on our routing station, and let's say that's the fence and that's the bit. Now we're able to, once we find the center of everything and we've got our fence in line, and I've already covered this, so it's a bit of a repeat, But once we find that center, we lock that down and we let this board here become sacrificial if necessary once we start doing the fatter routing up here. Because once we have this attached to our lower, we want to do every bit of the machine work that's necessary in order to fit the truss rod in. And it's going to be about primarily about depths. So I hope that makes sense. And so what I'm going to do, let me go ahead and get this attached. Then I'll power the camera back up and show you what I did because I'm going to be doing it with tape and jet glue, CA glue, and then you'll see that it's perfect to do the job at hand. So we pause, get that placed on the left side of the jig, and then we'll be good to go. Okay, I got set up to glue this on. There's my tape. I'm going to press that in really well. And this little board might look like a piece of trash, but it is unbelievably precise. This is some of the 1800s antique pine that I have, and it's this piece is rift sewn, but it's extremely straight and very stable, and I know it's perfectly S4S, so I'll use it as a little template every now and then. So I got that in place, and then I've got that ready. And same thing here, I have my tape down, really pressed in really well. And what I did just to be safe, I drew another line, which which is exactly on 1/8 of an inch, and that will guarantee that once I put my template down, my jig down, that I don't get off a little bit. Now keep in mind, if you wanted to, since you already had your center line, you could just take this directly to your center line and then let your jig become sacrificial in that it would get routed out. And that way you could just start doing initial route work until you start cutting off a little bit at a time until you cut off exactly 1/8 of an inch. And then you realize, well, if I'm that close, I'm close enough to go ahead and raise the bit on up to start machining the actual material at hand. And I don't think I'm going to be able to do this on camera because I've literally got to pull it down here. But the way you would do it is you would you do it just like this right here. But I may have to take it off the camera. Okay, what I'm looking for the footprint of the actual workpiece. And then if I want to protect this edge right here, well, then that determines how much glue work I do. But I don't have to protect that. This is the medium. CA. Got it from Hobby Lobby. That and I can assure you that is plenty strong enough. But I'm going to do some real small ones down here. That will guarantee that it's just beyond plenty strong enough. Okay. Cap. Medium strength. Okay. So now what I'll be doing is either starting at the bottom and lining it up or something. One thing you could do is you could actually come in and do the same thing with some small blocks right here. Put some tape here, put some tape on the back of your blocks and do a little block right there and do a little block right there. That way, once you come up here, you just go up against your blocks and you're set. Now that would be perfect if you're doing insanely precise machine work. If this is not insanely precise enough, then obviously we're getting pretty close to it. But to me, what would be incredibly precise machine work if I was wanting to cut that taper. So you see what I'm saying? I'm giving you Cowboy's way of doing the same thing in order to cut your taper. and then you would use it with a router bit that has a bearing on it. Okay, so I'm giving you some kind of cowboy trade secrets there, but you don't have to have really high end equipment in order to pull this stuff off. So I'll see if I'll try to keep it on the camera, but I don't think I'll be able to because after I've got this much, and then what you want to do is make certain that you don't get off a little bit and just kind of identify where you need to fold over. And I'm pretty much close to the end. So see if I can keep it on the camera, but odds are I'm gonna have to. Yeah, I'm going to have to at a minimum pull it like this right here so I can sight down it. I'm still not making contact yet, but I'm looking down at. I love that little light. It's awesome for this, but that'll guarantee when I'm sighting down there that I don't get lost in some sort of grain. I'm allowing my middle finger to kiss up against the neck lower. Give the glue time to work. And you'd be surprised if it is off just a little bit because of those little round drops. You could do a little bit of an encouragement within the first second or two, maybe the first 3 seconds. But right now, she's locked into place. And if it's wrong, tear it off and start over. Because whatever it is, that's exactly what your truss rod is going to do. Okay. So now at this point, I know I'm glued plenty strong enough, but I'm about to put some clamps on it, and I may just to show you how to do really safe work, go ahead and put an adder right there. But let me put a clamp on it. I think that'll reach. Yeah, that should reach. And what I like to do here is just clamp it down, move it, clamp it down. Because that jet glue glues, it dries so quickly, you don't have to leave it clamped. But this just guarantees that whatever little bit of dollop you had there, that it really spreads it out. Because you'll get a false reading if you just do it by hand. But if you really put some crushing clamp pressure on that, you're guaranteed that any wet jet glue that's in there will get crushed out, and it'll really flatten this baby out. And it looks exceptional. So, and I wish I had have gotten the guy's information that I learned that from, but he is a guitar builder. He was on YouTube. I saw this about 9 years ago, and he was showing how he will jet glue his fretboards down to a template with that, and then he'll do all the machining on the router table. I thought, that is brilliant. I'd never seen anybody do that. And I was thinking, there's no way that's going to be strong enough. That's dangerous. That can't work. But sure enough, it works extremely well. And all of the work that I just did there was probably, I'm not going to say that's overkill. I think it was a full strip of tape, but you probably could have put a 5 or 6 inch strip down here, one in the middle, one up there. But this guarantees that we have an exceptional, bond. Okay, so I've talked too much. Let me go do some work, and then we'll build the neck. Just want to show you something really quick here. This is what I was talking about. Um, you might think, oh man, you're wasting all that tape. You know, it depends on what you're working on. You know, so this is where you'll put your CA glue on two different sides, on the bottom and on the side, the bottom and the side, and it'll really lock that thing into position. So let's do just that, and I think I'm going to do it on this piece because it's a little bit more narrow down here. I had to work kind of fast because of gravity. Maybe not. And when you do push it down, you want to slide it about a 1/16 of an inch, just enough to make certain that it locked into position. Because if you're restoring a extremely valuable instrument or something like that, there's certain things where mistakes, honestly, that's not even an option. And there are certain times when you have to figure out. You might spend all day long just designing a jig that will guarantee, and I mean truly guarantee, that you're almost 100% successful in your job. And if you ever doubt anything that you're about to do, one or two things are about to happen. You're about to get hurt really bad, or either you're going to lose your job. And I broke my left arm completely in half. It was the most horrific thing I've ever experienced. And the job I was doing, uh, I knew better than that. I had worked in construction for way too long to have done something like that. And man, you talk about, once it happens, it's over before you even know it. So let's guarantee that we do a good job and that we're safe. And if we have doubt, then there's our answer. We need to back up and punt, or either go cut the grass. That should be plenty safe enough to keep it extremely stable and do the machine work. So now I'll go do the machine work. Okay, get that identified. Took about 15 minutes to just really double check everything and get set up. And because you're reading everything kind of upside down, just make certain that you trust your measuring instruments. My first kiss was a little bit too far that way, so when you pull it off your router table, don't flip it over this way, because you'll have to convert that to the opposite movement in your fence. When I pull it off the table, and I look at it this way, and I noticed that, oh yeah, I was way too far in there, so that meant that I needed to open the fence up a little bit. So that bit served its purpose strictly for alignment, and now we can put it back in its position. And then I like using this little bit here just to rough out, do all the heavy lifting and the mass work, and then I'll finish out the bottom with this. But just make certain that just try to remind yourself, don't go all the way down to the bottom, because you will have then lost the ability to do the radius bottom. You want to stop this mass out bit probably about right there. And that's leaving about 1/8 of an inch steel sidewall material to cut out, so that once you do convert over to this bit, you're only making probably 2 passes. Okay, so I'm going to load that one up, do the whole job, and then we'll come back. I might come back after 1 or 2 passes. Yeah, I will, just to show you how shallow I am as I'm starting out. And I don't really have to do anything to guarantee that the jig is aligned, because once I identified that center with this little bit, anything that I chuck up in that router table, now that I have not dared move the fence, will cut on the center line. Okay, so identifier bit, mass out bit, then we'll start radiusing the bottom of the channel. I forgot to cover something that I did cover briefly a little while ago, but this is definitely the time when you want to come in and assess where you want the truss rod to end. And I usually end them about an eighth of an inch beyond the top of the nut. So that will then allow me, let me double check, make sure I'm where I want to be. Then I'll come in, make this mark right here. And since I'm working on the table, I'm identifying everything from this side over here. So I transfer that mark up to right there. And I know that's my stop point when I'm on the table. See, on my router table, I have a pencil line drawn showing the perpendicular, center of the bit, regardless of how big the bit is. So I know that when that mark gets up to, when I get up to about right there on my mark, I know that I'm close enough for rock and roll to stop. And when you do stop, this is so important. One of two things. Once you make the cut, it's going to load up a little bit back here. Typically, I'll do the cut and then I'll pull completely out of the cut, and that cleans the channel and blows every bit of the dust out. But at a minimum, what you just make certain that you don't let it jump. And you guys are the carpenters. You do whatever it is that you do to keep routing safe, but just try to keep it from jumping, because if it jumps, wherever it jumps, you're going to get that identifying cut in your work. So now, let me go make the first pass. Okay, had to back up and punt a little bit. This was off about 64th of an inch that way, and I did make the first pass, and it was a bit of a learning curve mistake for me. I should have taken the 1/8 inch bit and followed all the way down to verify that I truly was on center. I only checked it up there, but it was a bit of a mistake. So I pulled everything apart, redid it, just put the one in the center. That's plenty. And I just made the second pass, which is correct. Now I'm 100% confident that my center pencil line is exactly 1/8 of an inch off of that, and she's perfect. So that's the cool thing about the little fillet. Will go atop that, and the epoxy will take care of any bit of slight imperfections on the top side, but the actual channel itself, wherever the truss rod is, it's probably out in the backyard. So nonetheless, it'll line up perfectly on center. That's critical. You can't have your truss rod even a 64th of an inch off center, because it will not work properly. So, all right, let me make the next pass, and then we'll try to knock this video out within about 10 minutes. At this point, I've made a couple shallow passes. Turn your truss rod upside down, lay it in the channel. Because I'm not really measuring anything just yet, you can then identify when you need to stop doing your mass out. Because right now I'm about a 64th of an inch away from it beginning to radius, so I wouldn't want to make any more S4S cuts, or square cuts. Getting fairly close down there. So anyway, all's well. And now I'm going to change over to a radius bit, run those passes, and bury it into place, and we'll be getting closer to finished. Okay, cover a few things here. If you were going to make a fairly thin neck I would say this is the threshold because this is what the truss rod was designed for, to actually flush out with the top. So, but obviously, because all that's in the way and I'm not finished up there, can't really show you the finished product just yet. But what you want to do is push all the way up against that and then monitor where truss rod is ending, and then ask yourself, is that what you want? Because once you come out of that, once you pull that bit, you're going to be changing heights again and transferring over to the 3/8 inch bit for the end. So you want to make certain that you've got your length. It'd be better if you ran about 1/8 of an inch too deep rather than be a 16th of an inch too short, because the last thing you want is this thing getting up here in the way of where the I do have one, where the truss rod nut, the truss rod cover nut will need to go. I mean, screw will need to go. Okay, so better to be a little bit deeper, and but I've just learned from all my builds, as long as I'm about 1/8 of an inch, I'm good to go. So what have we got here? Right now we're flush. This would be perfect if we're doing a fairly thin neck, but since this is a 50s replica, we're not going to be building a neck under 7/8 of an inch thick finish, total finish thickness. So I'm going to take it down about another 1/16 of an inch max, and then that will receive my mahogany fillet. So should be on the same page there. So let me make one more pass, and basically all I'm doing, I'm just over at the saw, at the drill, over at the router station, just making very shallow adjustments, and I go in about an inch and just check it, and then I got a good feel for the rotation that I make, how much bite it's going to take. So it's fairly easy once you figure out your tools. Okay. Okay, dial back in. Next thing you want to do after you've got all your machine work where you want it, you know that you're bedding properly. You've got the proper depth, that way, and the depth that way. One thing you want to do at this point probably is, I'm sorry, I'm going to show you the machine work down here. I'll give you an idea about where you want to be. Now, I usually come in with a little bit of wax, and I'll show you in a little. I'll go ahead and talk about it briefly. I usually put just a little bit of wax around the chrome areas, and on the end, or actually it's this Renaissance wax polish, and then that guarantees that any epoxy that might be in there, I want this truss rod to be able to move ever so slightly. I don't want it to be glued in anywhere, but I don't want it sliding around either. So, but if that makes sense, because once this bows, I just want to have a little bit of movement, because you might run into a squeak. So anyway, stop talking about that. So at this point, you're ready to see how well your work turned out. And that shows you what you can expect to see when you start removing the tapes. Stays fairly clean. See, that's from a different, never mind. And it's funny, I was thinking like a past video I did where if you're not careful, if you put too much of the jet glue, it'll penetrate through, and that's exactly what happened. A little bit penetrated through, so it's no big deal because it's all going to get machined off. So 9 times out of 10, it's going to protect the surface that you tape to and you work to. So very happy with that coming together. Let me get rid of that tape and stay as organized as I can, because this is such an incredibly long video for me that I can't even remember what I talked about in the last time I paused. So just know that in this design, it has to step down. It has to step down right there. It actually steps down again, but I go ahead and just do one machine step. So should be good. And this is where I was talking about, I'm gonna throw myself under the bus. I got off a little bit right there. So it's no big deal. I'll make the little general repair. But the most important thing was that the actual truss rod is on center. I've already covered that. So because see, it will be getting a fillet. It'll be getting the fillet up there anyway. So, but here's probably the most important part from a structural standpoint. That's 1/4 of an inch route. This is 3/8 of an inch route, radius bottom, all that jazz. We've already covered that. I pre-machined these little pieces here in order to fit in that hole. And then this is some maple. I'm not sure whether I'm going to go with maple or whether I'm going to go with the mahogany, but that will get epoxied into the neck. You guys that have been around for a while have already seen this, and what it does is it guarantees that that radius bottom cradles around that piece. Therefore, when I do all the final glue up, everything is just so solid. And I have to do a little bit of rabbet joining right here in order to allow that piece to go further down. I'm not going to start talking about that, but nonetheless, just know that there'll be epoxy in there, and that's what I meant by I put the wax on that, so that I don't want it too stiff in there. But I'm about to do all that work, probably off camera, because this is turning into such a long video anyway, and if anything, it's probably boring. But the next thing will be the mahogany fillet and epoxied in, glued overnight, dried overnight. And as soon as I glue that fillet in, it'll stop right here, and then this piece will travel all the way up. That's why I have to do the rabbet joint. And I just let this run long as it dries. And then I'll come back tomorrow and do all the machining. And within 1 or 2 passes, it looks like that right there. You can see where that's all stepped in. So it allows for a very nice surface, so that once you are gluing your fretboard down or epoxying your fretboard down, and very rarely do I epoxy the fretboard down. I like to put them down with tight bind because I can definitely control it. And also, in the event the guitar took a catastrophic break in the headstock, fretboards are not cheap. And if anything, if they were going to replace the entire neck, they would very easily be able to remove the fretboard, and then therefore they could just take a saw and just cut the neck off of the body and machine it all out, and then reuse the fretboard with all the beautiful, inlay and the frets and all that jazz, and that'll save everyone a whole bunch of money. So check the time. 53 minutes. It's a long video, but no sense of stopping now. Let's what should I talk about? Because I've gotten so in depth in this part of the build. Oh, this is what I need to talk about. Yeah, I knew there was a reason not to end the video. At this point, this is unbelievably critical. You got to find out what this dimension is right here. This depth. And I already did a general assessment. I did a general assessment when it still had the jig attached to it, but now this is going to be, well, I won't go that far. He'll stop up here. These are your reference marks for any finish machine work that you do. See, now I'm assessing the depth back here, and So that lets me know how much I stepped. And I don't know if it's showing up. I know there's going to be the glare, but what that tells me is I've got about 3/16. So that's the first fret location right there. And then at the first fret location, I hope you can see it. I can, but I don't know about you. But I'll just put the pointer where the bottom of that route is. It's right there. So you certainly don't want to sand into that. And the good thing about this design, I actually that center that you see right there, that's the finished guitar. This is exactly 7/8 of an inch at the first fret. Already pre-machined it, so I'm 7/8 of an inch. I add my 1/4 inch fretboard atop that, and I'm sorry, let me back up. Sometimes I get ahead of myself. The finished guitar at the first fret is 7/8 of an inch thick. This dimension right here that you're looking at is 5/8 of an inch thick. I pre-machined this taper from 3/4 of an inch, and I'm not misspeaking, 3/4 of an inch thick here at the 11th fret, 5/8 of an inch thick at the first fret, pre-machined. That way it guaranteed that I had my heel designed and everything and all that jazz was where I wanted it, so that when I come in and do all this hardcore machining, I just work to my finished points and I don't have any more shaping to do. Because in other words, if you change gears and said, I'm going to turn this neck into a shredder, well, just know this, it's going to have to be a shredder that you can't be under, what would be 7/8, 12, it would be 13. You could probably go down to 13/16 of an inch thick, and that's pretty much a 60s neck. So you could take off a little bit more if this was felt a little bit too thick, but I wouldn't recommend it. My suggestion at this point, if you're really wanting a super thin neck, then and I'm going to spend about 10 seconds with this. You could take your fretboard. This is from Stuart McDonald. That's not 1/4 of an inch thick. It's under 1/4. So if you go with their fretboard, this is going to be closer to 13/16 thick. But since I'll be building my fretboard custom out of the Gabon ebony or either the rosewood, my fretboards are going to be exactly 1/4 of an inch. Exactly. Now, this one is over 1/4 of an inch by about 32nd of an inch. It's the one that's on this little, we'll call it what's his name? Green? I can't think of the guy's name. Well, I think Ted Green's the jazz pro. I can't think of the guy's name. Fleetwood Mac, the Greenie. That's the fretboard material that's on that guitar. It's super thick. It's like a cello. And if I were to do that on this one, but then with the intention of coming back here and sanding this, I'd be getting too dangerously thin. Okay, so I spent more than 3 seconds with that. I shouldn't have spent so much time talking about it, because sometimes I go off on a tangent talking about the hypothetical stuff, only because I'm trying to help you head off a catastrophic situation later on. But sometimes it's probably a little bit overwhelming. So, but if it saves your guitar, it was for a worthy cause. So what are we here? We are exactly what I just said, 5/8 of an inch thick here. We've got close to 3/16 of an inch material left. After it's all said and done, I'll be able to shave this just a little bit. But if I changed gears here in the last, I wanted to go with a super thin, like 60s faster neck, then I might go with like a Stuart McDonald fretboard, or either just machine my fretboards a little bit thinner. And when I say a little bit thinner, just barely under 1/4 of an inch. Okay. Take the time. Probably going to pause and get organized and think about how I want to end the video. I'll provide some metric calculations here. 13 millimeter is what that's going to be. Yeah. Again, this is very close to being a finished lower. It's within very close. This is 17 millimeter. And now I'm at the first fret. So machine your lower 17 millimeter, put a whatever quarter inch is that fretboard on it, and you'll have a 59. It's going to feel like a 59. And you do whatever you want back here, but I usually start out a little bit thick, and then I thin this out by hand when I'm doing my final shape work. But so 17 millimeter at the first fret, 13 millimeter depth max. I wouldn't go over that. You're going to start running into critically thin dimensions. It'll still work, but nonetheless, I'd recommend staying within those parameters. Most important thing, this is why I don't like using, or I'll just say this is why I like working with the epoxy rather than tight bond, because I'm able to seal this, or any work that I'm doing, I'm able to seal it with my nitrocellulose lacquer, and then I can come in and epoxy my fillet in and not worry about getting a good bond. If you weren't go, if you were going to glue this fillet in with a tight bond, I'm not sure what sort of glue joint you would get if you sealed this first. I'm not saying it would be poor. I'm saying I don't know. But I do know beyond a shadow of a doubt that even though I sealed this with the nitro lacquer, I know for certain that the epoxy is going to be super strong and is going to adhere really well. Even if I glue that, even if I epoxy that fillet in within the next 30 minutes to an hour, I'm going to get an exceptional joint. And I wouldn't be that confident with a tight bond. If you don't have a small brush, make your own. I just cut all that china bristle off of an old brush, and these make excellent little primer brushes because you can really get in there. So I'll end the video right there, but at least now I have documented proof that I sealed all sides. Very important because especially for you traveling musicians or guys that are, if you're selling guitars to ship worldwide, and I've shipped them all over the place. I'm always really considerate about the climate that it might be going to, and it might be going to a climate that is insanely brutal. And when I say that, you want to make certain that there's no exposed edges, because just because you put that truss rod cover over that doesn't matter. Whatever climate the guitar's in, it's gonna that humidity is gonna creep right down through the center of the guitar, and possibly warp the neck or cause it to be hyper sensitive to climate change. Because one day you're touring Brazil, the next day you're in, I don't know, pick your location. You're back in America, and then you're in Europe, when you're either in the Alps, you're in Switzerland, where it's freezing cold and super dry. So you got to build your guitar to handle the climate change. And as long as you work with wood that's around 6% moisture content, or possibly lower if you can get it, 6 to 6.5% is fine. It's your target. You can build that guitar, and then you can pretty much ship it anywhere in the world, whether it's Louisiana, where it's really moist and high humidity, or to Arizona, where it's dry as a bone. And better to have wood that's a little bit overly dry than overly moist. Now, if you were building a guitar in, let's say you lived in South Florida and you built the guitar in a moist climate, just know that odds are you'll never be able to ship that guitar to Arizona. It'll need to stay in the South. So don't do those things. Build. That's why I wear a long sleeve shirt. It's freezing cold in my basement shop because I keep the moisture content or I keep the humidity as low as possible, helping keep the wood under control and it's well acclimated. And therefore, I know that once I ship this guitar, if I do, it'll always be very dependable. And that little bit of sealer right there makes all the difference in the world. So I appreciate you guys sticking in. I if you're watching this video, then it means that I uploaded it. But I'm going to actually watch it a couple of times, and make certain that it was really worthwhile. If not, I'm not going to upload the video. So otherwise, if you just watch the video, then I deemed it worthy of being uploaded, even though it was probably kind of brutal where I was doing all the pausing and changing and probably lost my train of thought a lot of times. So thanks for your patience, and I appreciate you guys dropping in, and I'll see you in the next video.